Hi there. Welcome once again to Solving Quadratic Equations, Applying, Extracting Roots. Learn with me, your teacher Jen. So, this lesson addresses this competency. Solve quadratic equations by extracting roots, and that is from grade 9. But of course, that is for grade 9, but we can actually make use of this lesson as a review in preparation for solving for the zeros of a polynomial function, which is what a grade 10 student is interested in. We apply the square root property we're in. A quadratic equation in the form of x squared is equal to k, meaning to say we have an incomplete quadratic. There is no middle term, which is, in general, the bx, or b times x. So, if k is greater than 0, meaning to say k is positive, then there are two distinct roots. Distinct meaning there are two different roots. While if k is equal to 0, then there is only one root, and that is 0. While if k is less than 0, meaning to say a negative number, then there is no real root. We will discuss what root then would it have later on. So let's apply extracting roots in solving the equation x squared minus 25 is equal to 0. So first step, we isolate this x squared. How do we do that? We add a positive 25 to both sides of the equation. Why a positive 25? Because that is the additive inverse for negative 25. And our goal is to have an x squared on the left side and the constant on the right side. After doing that, then we have to apply the square root property. We take the square root of both sides. Again, taking into consideration whatever you do on one side of the equation, you do it to the other side. So that we say square root of x squared is equal to the plus or minus the square root of 25. When you extract the roots, there's a positive and a negative root. Simplifying that, we then have what's the square root of x squared? X. What's the square root of 25? A positive and a negative 25. We then have two values for x sub 1, which is the positive value 5, and x sub 2, the negative value 5. Then you have to check whether the two values do satisfy the equation. So substituting in x squared minus 25 is equal to 0, x being the positive 5, you square that, minus 25, would that be 0? And we can see here 25 minus 25, it's really 0. So we see that the left side is really equal to the right side, meaning to say the statement is true. What if x is negative 5? So we have negative 5 squared minus 25 is equal to 0. When you square a negative, it becomes a positive. So what do we get? We now have 25 minus 25. Will that be equal to 0? And yes, 25 minus 25 is 0. And the right side is also 0. Thus, we can say that the solution to the equation is the set of negative 5 and 5. There you have it, the first example. Next, another example. We have solve for x squared minus 16 is equal to 0. It follows the same format as in the previous, but this time there is a coefficient of x squared, which is 4. So, first step, isolate the x. What do we do to isolate the x? We transfer the negative 16 to the other side, changing its sign, or we add a 16 to both sides of the equation. Thus, we will be arriving at 4x squared is equal to 16. Then, Since we have a coefficient of x squared, which is 4, we divide both sides of the equation by that coefficient 4. Thus, 4x squared divided by 4 is equal to 16 divided by 4. And what is the result? You have x squared is equal to 4. Then we go to step 2. And what is step 2? You apply the square root property. Again, 4 is a positive number or greater than 0, so we are expecting two different roots or two distinct roots, two distinct solutions. So we get the square root of both sides. And when we get again the square root of a number, remember positive and negative, so that we have the values of x sub 1, that would be a positive 2, and x sub 2 will be a negative 2, considering that square root of 4 is positive 2 and negative 2. Thus, you do the checking, and the solution would be 2 and negative 2. What about if we have this equation? 4x squared minus 45 is equal to 0. How are we going to do this? Similarly, what do? We isolate the x squared so that we now have transferring your negative 45 to the other side, it will become a positive 25. Let me go back to that. So that we now have 4x squared is equal to 45. And then take note that we have a coefficient of x squared, which is 4. Thus, we divide both sides of the equation by 4. 4 divided by 4, we get an x squared. And then we have the other side, we cannot divide 45 exactly by 4. Thus, we write it simply as 45 fourths. We apply the square root property. We take the square root of both sides, and we have the square root of x squared is equal to, do not forget, this is the positive square root of 45 divided by 4. Since we are talking about radicals, then remember that we can do distribution and say the square root of 45 divided by the square root of 4. So that x would now be equal to positive, negative. What is the square root of 45? That is actually a perfect square, 9 multiplied by 5. While of course the square root of 4 is 2. Thus, we now have x is equal to positive and negative. What is the square root of 9? The square root of 9 is 3. So we can bring that out from the radical, and we retain the 5 inside because we cannot take the exact square root of 5. Then that is divided by 2. So what is the first value for x? It's the positive 3 times the square root of 5 divided by 2. And the second value would be the negative 3 multiplied by 5 divided by 2. So again, inasmuch as RK, when transferred to the other side, is positive, then we have two distinct roots. On to the next. We have solve. The square of the sum of x and 2 is equal to 25. The left side is the square of a binomial. Can we still apply extracting square root? Of course, because we have technically one term on the left side and one term on the right side. Thus, we don't need to isolate because we already have isolated terms. So we apply the square root property, and we take the square root of both sides. The square root of the square of the sum of x and 2 is equal to positive and negative the square root of 25. And when we extract the square roots, we have x plus 2 is equal to, what is the square root of 25? A positive and a negative 5. Thus we can actually Continue and simplify. We transfer your 2 to the other side, or we add 2 to both sides of the equation. We now have, okay, transferring that, you have x is equal to negative 2 plus or minus 5. Thus, simplifying now, or we solve the resulting each resulting linear equation, or we simplify, we now have the first one being the positive. So we say x sub 1 is equal to the negative 2 plus 5. And what is negative 2 plus 5? You have a positive 3. Then the other is x sub 2, which is now equivalent to negative 2 minus 5. And what is the result? You have x sub 2 is equal to negative 7. You do the checking. Okay, let's do the checking. We check whether we still have a true equation, a true sentence when we substitute these values. When x is equal to 3, so 3 plus 2, we square that. Is that equal to the right side 25? What is 3 plus 2? 5. You square it. What is the square of 5? 25 is equal to 25. Yes, that is a true statement. What if x is equal to negative 2? Thus, we now have, we check, negative 7 rather, plus 2, we square that. Will that be equal to the right side 25? What is negative 2 plus negative 7 plus 2? It's a negative 5. And when you square a negative 5, what is the value? It's 25. And that is the same as the one on the right, which is 25. Thus, we say the solution would then be the values negative 7 and 3. Let us get used to writing first the lesser, or we arrange the roots from the list to the greatest. Okay? Then we have, similarly, if we have the square of 3x plus 3 is equal to 27. So how are we going to do this? All right? So the left side is already a square of a binomial. So like the previous example, we simply apply the square root property. We take the square root of both sides. Thus, we have the square root of the square of the sum of 3x and 3 is equal to positive or the negative square root of 27. And when we extract the root, we have 3x plus 3 is equal to positive or negative 3 times the square root of 3. How did I get that? Remember that your 27 is 9 multiplied by 3. So that you will now have the square root of 9 times the square root of 3. And what is the square root of 9? That is 3 times the square root of 3. All right? Then we now have to simplify. In the left side, there is a positive 3. So what do? We add negative 3 to both sides of the equation so we can isolate the one with the variable. Why negative 3? Because we have there a positive 3 and the additive inverse is a negative 3. Thus, we now have, shortcut would be to transfer. 3x is equal to negative 3 plus or minus 3 times the square root of 3. All threes. Then, since we have the coefficient of x, which is 3, we're going to divide both sides, or both sides of the equation by 3. Thus, 3 divided by 3 will give us 1, leaving an x is equal to negative 3 plus or minus 3 times the square root of 3 divided by 3. And you can see here that both terms, negative 3 and 3, the square root of 3, are divisible by 3, giving us, okay, negative 1 plus or minus the square root of 3. Because if we can rewrite this, we can do this now as negative 3 divided by 3 plus or minus 3 times the square root of 3 divided by 3. And we will see here that 3 divided by 3 is 1 and 3 divided by 3 is also 1. Thus, we can again separate and simplify each resulting linear equation, starting with the first x, where we consider the positive, -1 plus 3, plus the square root of 3. And the other, x sub 2, is -1 minus the square root of -3. Thus, of course, we can no longer simplify that because one is a radical and the other is an integer. Thus, we have the two values of x. We have -1 plus the square root of 3 and -1 minus the square root of 3. What about if we have x squared plus 16 is equal to 0? Likewise, we have to isolate x squared on the left side. So what do? X plus 16 is equal to 0. We transfer the 16 to the other side, shortcut. Then it becomes a -16. Now take note that this is a -16. And what did we say a while ago? If we have a k which is negative or less than 0, there is no real root. Let's see. So we still apply the square root property, taking the square root of both sides. What's the square root of x squared? That's an x. Then plus or minus the square root of -16. And since this one is negative, then we say that there is no real solution. On the part of a grade 9, what about if you are a grade 10 student? Then we have to say x, we can simplify that and say x is equal to plus or minus what is now your 16, your square root of -16. That's the square root of of 16 multiplied by the square root of -1. And what is the square root of 16? We have a 4. And then we have there the square root of -1. We are going to discuss this when we will be into the zeros of a polynomial function. For the meantime, we say since we have here a negative radicand, it does not follow the definitions and the conditions for the for the extraction of fruits. So no real solution. Okay. Next, remember, what if we solve x squared is equal to 0? Even if you're going to apply extraction of fruits, you have here x will still be equal to 0. So there's only one root. There you have it. Again, let us take note. When we're solving an equation, quadratic equation of the form x squared is equal to k, if k is greater than 0, two distinct real roots. If we have k is equal to 0, there's only one root, which is 0. And if k is less than 0, no real root. Again, let us look back. And can we now say that I can solve quadratic equations using extraction of roots? Can we also say that we really can now solve with mastery linear equations in one variable? That should be a check and another check. Thank you. See you in the next video. Again, sources where I have taken some of the contents and pictures. Once again, thank you for listening. Thank you for watching. See you in the next video.